Collecting information and categorizing soil and land resources helps experts make informed decisions on whether a particular site is suitable for a project or development they are hoping to undertake. A land resource survey is a balanced approach that includes mapping, modelling and monitoring within a broad environmental context. Land management is the process taken to achieve a land use outcome and is very much the how the land will be used. Once information is collected and analysed as a land use survey, the experts, usually agricultural or environmental engineers, will work out the best practice for how to manage the land. In reference to the size of the site or project, the scale of the survey must be decided. Intensive land use requires survey scales to be smaller with higher resolution graphics to ensure the accuracy of land, soil, geology, topography represented on the graphics produced. Examples of high intensity scaling are intensive land use development, urban horticulture and engineering uses, local urban structure planning, detailed farm planning, and property development planning. These surveys are usually depicted on a map with a scale of 1 to 10,000. Low intensity maps, usually at a scale of 1 to 100 or 1 to 250,000, cover a greater landmass in less detail and resolution. This type of land resource map is typically used for regional plans, planning rural shires, overview of management issues for large catchments, or general planning for pastoral shires. Land resource surveys are often the basis of planning for a new development, for a new project or development. These often are undertaken without knowing which parties will be reviewing the surveys and interpreting the information, and how and if they have the institutional information to use it properly. This is because there is not always integration between environmental, social and economic factors. Planning is best made use of when the people are consulted throughout the process and the social, economic and environmental aspects are weighed up as part of a cost-benefits analysis. As part of an environmental impact assessment, a cost-benefit analysis should be conducted for the project or development. Once the project objectives have been set, the social, environmental and economic costs and benefits are established. Alternatives that meet the desired objectives will also be analysed for their costs and benefits to ensure that an alternative is not more feasible than the original plan. Some of the costs and benefits only become evident over a prolonged period of time. Resource management continues to monitor elements of the cost-benefits analysis until well after the project has been completed. Land classification gives developers information regarding what projects are suitable for different land classes. For agricultural land, can be identified as one of 5 classes or categories, each having its own benefits and limitations for particular farming. Land for agriculture is classified by soil, geography and topography. Land classification can be done on different scales and resolutions, where grid squares on a map are given their own classification. Using topography as an example, low-lying land, which is prone to flooding, rules out any urban, commercial or industrial developments, as the land is more likely to be used as parkland or conservation habitat for wildlife. Thank you for listening.